So for a long time, I've been very wary to talk about phase diagrams in my videos because I really kind of view them as a very simple complex, and there are other concepts that really need, in my opinion, need my attention more. But enough of you have asked for it, so I'm going to create a video on phase diagrams, and let's talk about the types of phase diagrams, and let's talk about the next video we'll talk about the types of questions you can be asked about phase diagrams. So there are three properties that uniquely define matter: pressure, temperature, and what's called molar volume. Now, molar volume is going to be a V with a squiggle above it. That means that we're taking the volume and divide it by the number of moles in the system. Now, a phase diagram can be three-dimensional, in that it has all axes of P, T, and V. But traditionally what we do with a phase diagram is we only report two of the axes and we kind of leave the third one not there. It's kind of like the devil in the details. So we name phase diagrams based off of the XY axes. So we can have a PV phase diagram, which is pressure versus volume, a VT phase diagram, which is volume versus temperature, and a PT phase diagram, which is pressure versus temperature. Now, these give us different pieces of information. So the two I want to talk about in this video are the PV phase diagrams and the PT phase diagrams. Now, they do exist, so don't kind of lull yourself into a false insecurity. Most chemistry books only talk about the PT phase diagram because it's what chemists are most interested in, because they're the two variables we control easiest in the lab. We can control pressure by sealing the reactor, and we can control temperature with a hot plate or ice or something like that. The PV phase diagram exists because it gives you information on work. So if you ever talk to an engineer, they're usually looking at the PV phase diagrams, not the PT phase diagrams. So what types of information are contained in phase diagrams? Well, as the name implies, it gives you the phase of the material. Now, a lot of you may go, it's really obvious. It will surprise you on exam how many of you don't actually look at the phase diagram and try to answer the question. That's why you get the test questions wrong. For a PT phase diagram, what you are used to seeing is something that looks like this. And you go, oh, that's solid, gas, and liquid. Well, there's more than one solid phase, right? If you go look at my other videos, there's BCC, FCC, amorphous, crystalline. There are so many phases. So don't get into this habit of going, oh, it's just solid, liquid, gas. That's all there is. There's more than that on a phase diagram. But the thing about a phase diagram is once you know the pressure and temperature conditions, you will know uniquely defined what phase you're in because it will tell you. A PV phase diagram is going to look more like this. Now, our PV phase diagrams here are meant to give us information on work because the work term in thermodynamics is delta PV. Now, it works the exact same way. We just have to look at the phase diagram and know what's there in order to figure out what phase we have. But the unique thing about a PV phase diagram versus a PT phase diagram, if we look at a PT phase diagram, these are what are called phase boundaries. So present at these phase boundaries are both phases. In this were a solid and this were gas, we'd have both gas and solid present in equilibrium. But we don't know their ratios. And the reason we don't know their ratios is that hidden here is that volume. If we don't know the molar volume, how many moles there are in that given volume, we don't know the ratio of solid to gas. This will actually give us the ratio of solid to gas or liquid to solid or liquid to gas given our conditions of P and V. So, different phase diagrams give you different pieces of information. And the big thing here, I hope you're listening to, read the phase diagram. Do not assume you know the phase. Because again, it's kind of an embarrassing question to get wrong. If I ask you what phase is there and you say, oh, it's this, and that word is not anywhere present on the phase diagram, it shows me that you didn't actually read it. So, next video we'll talk about the details of a PT phase diagram, and then we'll talk about the types of questions that you can be asked about a PT phase diagram.